Hello everyone, my name is Ruizhe Zhang, and I'm from Center for Power Electronic System in Virginia Tech. My advisor is Dr. Yuhao Zhang. Currently, we are at the third quarter of this project, which is the surge energy robustness of gallium nitride power devices and modules, application-driven evaluation, and physics of failure modeling. The main objective of this project is providing key understanding of the surge energy capability of gallium nitride power transistors, including the surge energy withstanding process and capabilities, the device degradation models, the primary failure mechanisms. The expected outcomes include a unified test waveform to characterize the surge energy robustness for both single event and repetitive tests for various gallium nitride power devices. There will be also mission profile tests to identify the physics of degradation and failure models. We have built up this universal GAN test platform for unclamped inductive switching test, the UAS test, and the repetitive clamped inductive switching test. We have this universal GAN motherboard and identical daughter card. The system is designed to accommodate high voltage up to 2 kV, high current up to 60 amps, and high ambient temperature up to 225 degrees C. This motherboard daughter card system is built up to fit different packages from various vendors. And here shows the UAS test circuit. During the test, we will insert the daughter card into the motherboard. As we can see from the test setup, we use a power resistor to heat up the DUT and the thermocouple to calibrate the temperature. Let's take a look at the test results. For the failure trigger, we performed the single event UAS test at room temperature. Let's use the HAMT from component A as an example. On the left-hand side shows the typical failure waveform. We can see there is a sudden decrease of VDS when the failure occurs. And to find what determines this failure, we perform the single event UAS using different loop inductor values. And by changing this loop inductor value, the resonance period in the safe withstanding process also changed, which leads to different overvoltage duration T. Here we define the T as the time when VDS is higher than DUT voltage rating. On the right-hand side shows the failure boundary with different surge voltage time T. As we can see from this black dots, which is the peak transient voltage, VM leads to device failure. The VM leads to device failure shows little dependence on the surge voltage duration when the T is within tens of nanoseconds, which means the gallium nitride surge energy capability is almost solely limited by the transient breakdown voltage. If you want more details, you may want to refer to our recent publications in IEEE. We also performed the test at different temperatures. So as we can see here, for both HAMs from component A and component B, the VM leads to failure, sees little change with the temperature. So we draw the conclusion that the failure in the single event UAS test is not related to temperature or any thermal issue, and is a purely electric field induced failure. For the failure analysis, let's use a HAMT from component A as an example. From this transfer characterization, we can see that the gate remains functional after the UAS failure. And with the help of emission microscopy and FIB cut, we successfully found the failure locating at the drain side. And from the TCAD mixed mode simulation, it shows that the peak electric field locates at the drain side in this UAS transient. So all the evidence leads to the conclusion that the failure mechanism is a transient peak electric field induces a failure in this single event UAS test. For our future work, we will first do the repetitive surge energy testing, as well as the mission profile tests. And if you want more details about our test and results, you may want to refer to our recent publications. And we would like to thank you for all the assistance from CPAS and Lockheed Martin. If you have any questions, please feel free to contact Dr. Yuhao Zhang. And thank you very much for listening.